Hey scholars, welcome back to chapter 15. We're taking a look at chapter 15.2, which are what are the advantages and disadvantages of oil, since that's been the resource we've used most often, or at least the ones you're probably most familiar with on a day-to-day basis. So we're going to take a little bit closer look at oil in this section today. So obviously we depend heavily on oil. We use it mostly of petroleum, or what we call crude oil, which also equals conventional. Another name for it is light oil, and we use that the most. Overall. Fossil fuels come from crude oil and or natural gas. Those are our types there: fossil fuels, crude oil, natural gas. Oil extraction and refining, we're talking about those processes here. And in those processes of trying to extract those petroleum and fossil fuels, we actually get these things called petrochemicals, which are basically products of oil, of basically distilling the oil or refining the oil. And we'll take a look at some of those in just a second. But the world's oil consumption is quite large. Right now, we rely on it for quite a number of years, and the world's oil consumption at this point is pretty much off the charts. But I'll give you a little. The three largest oil used in 2007 were the U.S. using 24% of all oil, China using 8%, and Japan using 7%. And kind of the question is how long will that last? We've been kind of asking that for a while, but we're still kind of concerned with that. So here's the science in refining crude oil. So as it is crude, it's pulled out of the ground. It's very raw and has a lot of things to it, and there's things that can be made out of it. And what we do is we heat up the crude oil, and based on these temperatures, based on actually heating up these things and taking a look at the temperatures that are needed to produce these, it says the most volatile components with the lowest boiling points are removed at the top of the column. So the lower the boiling point, kind of the higher it is as far as the refining process goes. So if you heat it up, and this is the highest boiling point, which is asphalt, kind of the raw material, goes into making literally asphalt. Grease and wax and using solvents. Then diesel oil is kind of another one there. Heating oil for your homes, then aviation fuel, gasoline, and then natural gas is on the top. All those kind of has the lowest boiling point all the way to the highest boiling point. So as it is refined or heated up, as in the heating up process, it kind of separates into these things based on boiling point. So OPEC. Let's talk about OPEC for a little bit. OPEC stands for, literally OPEC stands for Organization of Petroleum Exporting Countries. And they actually control a majority of the world. So there's only 13 countries. They have 60% of the world's crude oil reserves. Saudi Arabia has 25% and 50%. But let's talk about the different countries within OPEC. And none of them are really, most of them aren't close to us. The countries that are currently in OPEC's members are Algeria, Angola, Indonesia, Iran, Iraq, Kuwait, Libya, Nigeria, Qatar, Saudi Arabia, and the United Arab Emirates and Venezuela. So none of them even close to us. The weird thing about OPEC is that no one really knows the size of the world's proven oil reserves. The UN and other agencies have kind of come in and projected future oil production based on the figures given them by the oil producing countries or OPEC. But there's a lot of secrecy with OPEC, and they're not really telling us exactly how many barrels of oil are left or how much resource they have. So there could be lots of oil resources. Most likely not, but there could be a lot more than they're really claiming, and they're again controlling most of the oil price of the world, and we'll talk about why that is in a little bit. So oil production peaks and flow rates to consumers, again, it depends on who's controlling the majority of that resource and who wants it badly enough, which is us. That's who controls the prices. So possible effects of steeply rising oil prices. As the oil prices go up, we're going to need to reduce energy waste. So we're going to need to either use cars that are more efficient on using the oil and the gasoline, or use products that are better energy efficient. Shift to non-carbon energy sources, so like maybe more renewable energy. Higher prices for products made with those different petrochemicals that are byproducts of the refining process. Also, higher food prices, which because of the transportation issue, it's going to drive people to buy locally produced food. Airfares will be higher. People will do less traveling. Either that or they'll have smaller fuel-efficient cars that can take a longer time to get them from point A to point B. And they might even use public transportation more. And that's what's really going to happen as we see those oil prices rise. And some of that might already be happening, and you're feeling the effects of it. So the United States actually, and this is the reason why our gas prices rely on OPEC quite a bit, and most of our government is trying to rely as least amount of possible on OPEC as much as possible. But the United States is still using much more oil than it can produce. It produces only 90% of the world's oil, and it imports 60% of the oil that it has. So because of that, we are kind of falling. At the will or whatever, we're kind of held up against the wall by OPEC as far as prices go. About 1/4 of the world's conventional oil is controlled again by countries that sponsor or condone terrorism. So that is kind of a problem too, since we try to fight against that. So it's an interesting kind of toss up with oil since we don't control a lot of it, and we continue to try to drill for it offshore of our own country to get this percentage kind of more even out or more one-sided towards producing it on our own. Unfortunately, we don't have a whole lot of those resources, at least that are usable and feasible. So one thing is, should we look for more oil reserves? Again, it's extremely difficult. It's also expensive and financially risky to look for more oil, especially in our own country. And to get to some of that, we actually have it, and we'll explain more about that later. But there is oil in our country, just very, very hard to get to and extract. A new role for bacteria in the oil industry might help with that extraction process. By using bacteria, we might be able to help break down things that are barriers from us to the oil. That might make our process a little bit easier. One of these case studies is the oil in the Arctic, and we've heard of this a lot. The U.S. Arctic National Wildlife Refuge, or the ANWR. It's not open to oil and gas development. It is a fragile biome, being the tundra. There's a lot of interesting species like polar bears, Arctic foxes, musk oxen that live in that area. But since the 80s, people and lobbyist groups of oil companies have been trying to do exploratory drilling in those areas for oil because there are oil reserves underneath it. The problem is that it's going to tamper with that fragile ecosystem. So there's been people lobbying back and forth, trying to get people on board, for both of those. And there's pros and cons of it. Pros are we get more oil and we rely less on OPEC. The cons are that we destroy habitats on our own soil. So and we run the risk of destroying those habitats. So it's kind of up in the air as far as who you want to side with. Eventually, I think we need to at least come away from oil as much as possible and rely on it less. That would help make this process a whole lot easier. So the amount that might be found in the Arctic is kind of projected U.S. oil consumption. This is the Arctic Refuge oil output over 50 years, so not a whole lot. And our consumption still rises. So, I mean, is it going to even make a dent if we do, go and try to tap into that resource? Who knows? Conventional oil has its advantages and disadvantages, mostly because of extraction, processing, and burning of it. We'll look at those advantages and disadvantages now. But the first one, let's look at advantages first. Ample supply of it, 42 to 93 years left of conventional oil. Pretty low cost, high net energy, we talked about earlier. Easily transported in between countries. Maybe it's run the risk of oil spills, but still easily transported. Low land use because you're going underneath the technology is well developed. We've already done it for a long time, and an efficient distribution system as far as pump, going to the gas pump. Disadvantages: you need to find a substitute within 50 years. We're going to run out of it. Large governmental subsidies are being put forth towards drilling of oil and trying to find oil. Environmental cost, again, not included in the market price. Your price would be going through the roof if they really put that environmental cost on there. Artificially low price encourages waste and discourages search for alternatives. I mean, I know we complain about gas prices, but if you look at, over in the European Union, they're paying $6-7 a gallon. That's why they have all these really small, short, smart cars that are only taking them from point A to point B in a very short distance. Maybe we would switch to that if we weren't paying only maybe a measly $2 or $3 a gallon, which I know I'm saying measly. I feel in my pocketbook too as it goes up. But eventually, what is going to make us switch or use less or be less wasteful? I mean, what is it going to take? It's probably going to come from our pocketbooks. Let's be honest. It pollutes the air when produced and burned. It also releases CO2 when burned. That's a bad thing, which we just talked about the greenhouse effect and global warming last chapter. Can also cause water pollution as well. So those are the pros and the cons. And if it does not get transported easily and safely, then we have spills, and that can cause major damage to the environment. Will heavy oil spills from oil sand be a viable option? So like the spills not being as it's dumped everywhere, but literally like a resource as a spill. Oil sand or tar sand contain bitumen. It's basically oil locked up in rock. And in Canada and Venezuela have oil sand and have more oil than in Saudi Arabia as far as oil sand goes. The problem with it is a serious environmental impact before strip mining. So strip mining is bad. It also has a lower net energy yield because, remember, you're taking a lot of resources to get it out of the rock. Is it cost effective? Probably not, even though they have a lot of it, but that might be, where we go next. Again, that will drive the price of oil way up because of those extraction costs and its lower net energy yield. Will oil shales be a usable resource? So oil shales contain kerogen, which is a different type of a burnable fuel source, and after distillation it becomes shale oil. 72% of the world's reserve is in arid areas of the western U.S. But there's a catch. So we have a lot of it, but it's locked up in rock again. Like I said, this part, the oil and sand and tar sand, is actually located in sand itself below the surface. It's in there, but it's just in between particles of sand. This one is locked up inside rock, and there's a lack of water needed for extraction and processing. So we have to use water to help with the extraction process. Again, to get to it and to extract it and to use it makes it as a low net energy yield. And this is an example of oil shale rock and shale oil. And there's also a way of getting this out, and it's called fracking. I'm not swearing, I promise, but it's called fracking, and it also allows natural gas to be released too. And I'll explain how that process is used, and that can also be a danger to our water source as well. I'm going to show you a couple of videos below this, this video to show you. But let's take a look at the pros and cons as far as heavy oils and oil shale. It's moderate cost as far as oil sand goes, the advantage of it. Large potential supplies, especially in our own nation or Canada. Easily transport within countries. Efficient distribution system in place because we can change it into, again, gasoline. Technology pretty well developed just for oil sand, not really oil shale. The disadvantage is high cost. Lower net energy yield, and it's going to cost a lot on the environment. And we'll explain a little more about that when you watch that video below this one. Severe land disruption, severe water pollution, air pollution as well. So not really the best option. But those are options for oil. If we stick with it, that's where we're going to be at as far as going to our last-ditch effort with oil. But that's it for this section of Chapter 15, and we'll talk next about natural gas. See you guys next time.